Hi, so in this video we're going to talk about isotopes. So what exactly are isotopes? Isotopes are elements that exist in the same family. So what we mean by that is every element has a number of members of its family that sit with it with the same atomic number but different mass numbers. And what we mean by that is they have the same number of protons, okay, but they have different number of neutrons. So this is key to understanding isotopes. So the protons are the same, but the number of neutrons are different. Okay, so take for example neon. Neon actually has three naturally occurring isotopes, okay? So it has three members in its family. All those three have the same number of protons, okay? So if I kind of make a table out here and I say protons and then I say neutrons out here, the three will have the same number of protons. So those three isotopes or members of the neon family will have the same number of protons but different number of neutrons, which means, turns out in the case of neon, one of the members has 10 neutrons, the other one has 11, and the other one has 12. Okay? So now if you actually add up the protons and the neutrons, you end up with something called the mass number. Okay, mass number. And so the mass number of these three members, so those three isotopes, is 20, 21, and 22. And so there is a way to distinguish between these when you write the chemical symbol of neon, and there's two ways, okay? Let's take a look at the first way. So the first way is you just write the symbol, the chemical symbol, and then you write the mass number with a dash. So dash, mass number. So the second member or the second isotope of the neon family is written as neon dash 21. And then the third one is neon dash 22, the mass number. So this is telling you that these three are different. Number of protons are same, but number of neutrons are different, hence resulting in a different mass number. There is another way to write these, okay? And the other way is you write the chemical symbol and then you write the mass number on top and the atomic number, which is the number of protons, below as a subscript. So the mass number is a superscript, the atomic number is a subscript. Okay, so the mass number in the first case would be 20, atomic number is 10. The second case would be 21 and 10, and the third case would be 22 and 10. So see, there's two different ways to write them. Usually we tend to, when we're talking about these different isotopes, we say neon 20, neon 21, neon 22. So to kind of summarize kind of how we write isotopes, okay? So if you have the chemical symbol, so let's call the chemical symbol, I'll kind of write it with a different color out here, okay? Let's call the chemical symbol X, okay? The mass number is written out here, so that's one way. And the other way is if you have the chemical symbol X out here, then the atomic, the mass number is represented by A is written on top, and the atomic number represented by Z is written below. So just as a reminder, number of protons is Z and mass number is A. Now what's interesting about isotopes is, even though you have these three different masses, oftentimes we tend to get confused and think that, okay, we'll look at the periodic table and figure out the mass numbers from the periodic table. Turns out the mass numbers are not in the periodic table. Any typical periodic table will not list the mass numbers. What they have listed is something called an average atomic mass, or commonly known as atomic mass. An atomic mass is simply the average of the masses of these three isotopes in the abundance that they are naturally available. Let's take a deeper look and try to understand what exactly that means. So out here we have listed the 3 isotopes of neon. The natural abundance, which means if you actually if you just take a sample from planet Earth of neon gas, you're going to find that 90.48% of that sample corresponds with neon 20, 0.27% corresponds to neon 21, and then 9.25% corresponds to neon 22. Okay, so that is the natural abundance. Okay, if you add these up, you will get 100%. Now, the mass, or the AMU, the mass expressed in AMU of this isotope is 19.992. The mass of this isotope is 20.994, and the mass of this isotope is 21.991. So what you have to do is to calculate the atomic mass, you have to find the weighted average of these 3. And the way you do it is, so I'm going to write weighted average is going to be simply this percentage times 19.992. So that's a percentage. It means if you take this, you divide it by 100. Okay, so that's going to be equals, so that's going to be 0.9048 because I divided by 100 times 19.992 plus the same thing we do with this divided by 100 times this 0.0027 times 20.994 plus this divided by 100 times this 0.0925 times 21.991, and then we simplify it, so this becomes 18.09, this becomes 0.06, and this becomes 2.03, and if we add them up together we get 20.18. This is the atomic mass, which is an average of the masses, okay, of all the 3 isotopes based on their natural abundance. And it's not a simple average, it's a weighted average because they're weighted differently. Now, if you look at the periodic table, so let's say you look for neon, what you're going to find is, I'll write in different color out here, you're going to find something that looks like this. You're going to find a box, you find neon, on top of the box you'll find 10, that represents the atomic number, so that's your Z. At the bottom of the box you will find the atomic mass, which is 20.18. Okay, that is, as I mentioned, the average of the 3 isotopes. I hope that made sense.